Engineers must consider the breadths of male heads when designing helmets. The company researchers have determined that the population of potential clientele have head breadths that are normally distributed with a mean of 5.9 inches and a standard deviation of 0.8 inches. Due to financial constraints, the helmets will be designed to fit all men except those with head breadths that are in the smallest 2.2% or largest 2.2%. So what is the minimum and maximum head breadth or helmet breadth based on these constraints? So I have already marked on my normal curve, and I knew to use a normal curve because it told us that these were normally distributed head breadths. And they also gave us the mean, so I have that marked here, 5.9, and the standard deviation of 0.8 is important for us to note. And we also see that they told us that the smallest and largest head breadths or that they want to not include in their helmet specifications are the smallest 2%, 2.2%, and the largest 2.2%. So percentages converted to decimal form, you move the decimal 2 places to the left, or in other words, divide by 100. So you see that I have the lowest 0.022 probability marked on the left tail, and the highest are the greatest head breadths of the 0.022, representing the 2.2% largest. Now, being that the curve is symmetric, I know that since these tails are the same exact probability or exact same area, that the boundaries are in the same distance location from the mean, which I haven't really illustrated all that well. I didn't know exactly where to put them, but I knew that I'm going to have one here and one here, and they're going to basically be the same number, just different signs. And the easiest one to find would be the one on the left, since using Excel, we can use the norm.inverse function when we know a probability, and specifically a left probability, and we can use that with the mean of 5.9 and the standard deviation of 0.8, and that will quickly and easily tell us what the minimum is for the head breadth that separates the smallest 2.2% of head breadths. Now, before I said that this number would be the same, just a different sign, but I misspoke because that would only be if we were dealing with a standard normal distribution where the mean was 0, the standard deviation was 1, and the z-scores were on the horizontal axis. But since we do not have a mean of 0 and a standard deviation of 1, these are not z-scores across the horizontal axis. And remember, they are head breadths specifically in inches, right? So being that they are specifically in inches, I can't just say negative 4.2 and positive 4.2 inches. That would not make any sense, of course. And the number that's over here is going to be greater than 5.9, which is in the center. So how will we know how to get this answer? Well, we can do norm.inverse again, but this time we want to use the area to the left of the right boundary, the maximum boundary. And if you do 1 minus 0.022, you will get the left area. So that's what we're going to use for norm.inverse here. 1 minus 0.022, the mean is 5.9, and a standard deviation of 0.8. And so there you have two answers that make sense for a range of possible head breadths or helmet breadths, head breadths that the helmets will fit from 4.289 inches up to 7.511 inches. That makes sense when your head breadths have a mean of 5.9 and a standard deviation of 0.8.